problem, which is a great problem. Refresh me. Are you in honors geometry?
No, I'm just in geometry.
Just in regular geometry?
Yeah.
Whoops. Hold on a second. You've apparently had trig, yes?
Yeah, we're like learning some things like SOHCAHTOA and stuff like that mainly.
Okay.
Yeah.
Because part of the problem for me is I don't know how much trig you've had as to whether we can use trig on this. Well,
yeah, we haven't learned that much. I mean, my teacher's pretty bad at explaining.
Let's take triangle 1. I'm not quite sure I know how to do this without using trig.
Okay, well you could...
I haven't looked at it long enough, and I'm not sure I want to spend the time needed. This is a 3, 4, 5 triangle, right?
Yes.
That is 37 degrees right there. That's 53 degrees right there. If I want to know what those angles are, then I could just say the inverse tan of 9 over 12 is going to be that 37 degree angle. That's going to be equal to 37 degrees. Do it on your calculator, that's what you'll get.
Okay.
I'm rounding it off to the nearest degree.
Okay.
Okay? Now that's going to be helpful because notice if I can figure out what all these angles are. Wow, what is going on with my phone? Okay, hold on 1 second. That's okay. If I can figure out all the angles on this triangle down here, the 5, 5 triangle, what are the two angles there?
Should I use the tangent thing again? Or is it just...
You could say the inverse tangent of 5 over 5, but that's an isosceles triangle. That's one of the more common ones you've dealt with. That's a 45, 45.
Okay.
Okay. And you kind of see where I'm going with this? If I can figure out this angle right here, excuse me, let me point with the cursor. If I can figure out that angle and that angle, then I'll be able to figure out all the 3 angles of the gray area.
Okay.
Okay. Now let's look at that top triangle. It is a 7, 14. So what is theta going to be? Inverse tan of what?
Of 7 over 14.
Can you do that on your calculator?
Yes, hold on.
And round it off to the nearest degree.
Okay, hold on, sorry. Okay. Inverse tan.
I can't believe they didn't at least put a 30-60 triangle in this mix.
Okay. Okay, 26 or 27 degrees.
That's 27 right there, which makes this one what? The one opposite. The other acute angle in triangle 2, what's it? If that's 27,
63.
Okay. Now, we have enough information that we can figure out what is this angle right there.
How would I find that? Just by...
Well, what do the 3 angles have to total to make a straight line?
180, that's right. Or no, 360?
No, straight line is 180.
Okay, minus 63. So 72.
Okay. How about this angle down here?
Hold on, 180 minus... That would be 82.
enough to answer our problem?
72.
Let's complete it. What's that smallest angle?
Okay, hold
What do
on.
those add to? Those three angles at the top.
Oh, so it would be 26 plus 27 plus 37, 90.
Okay, so what's the small one?
The small one in the gray triangle, 26.
Okay. So none of those angles are a right angle, so it is not a right triangle.
Okay.
Find the shaded triangle's area two different ways, indirectly and directly.
Yeah.
Well, indirectly is pretty easy.
Is that where you drop the altitude or?
Well, the way I can most immediately think about it is I can figure out the area of each of these three white triangles, right?
Mm-hmm.
And I can figure out the area of the rectangle. So it's the area of the rectangle minus the area of each of the three triangles. So what's the area of the rectangle?
Hold on.
The big outside rectangle.
Yeah. 168.
So it's the area of the rectangle minus the area of triangle 1 minus the area of triangle 2 minus the area of triangle 3, which is this one.
Okay.
That's going to be the area of the gray area. So
Okay.
what was it again? 168?
Mm-hmm.
What's the area of rectangle 1?
Or triangle 1, you mean?
Yes, sorry, triangle 1. Mm-hmm.
Okay. So the height would be 12, right? So 12 times.
Right triangles are always base 1/2 base times height. And you're looking at a base and a height. You don't have to do any calculation
Yeah.
to get the base.
12 times.
So it's
Wait, hold on, sorry.
6 times 9. Rather than just use your calculator, take half of one of the numbers, multiply it by the other. 6 times 9 is 54.
Yeah. So then you subtract that from 168.
Well, let's do it the way I've labeled it up here. What's the area of triangle 2?
Okay, so it would be 7 times 7, so 49.
And what's the area of triangle 3?
It would be 12.5.
Okay, now do that. And that's going to be an exact answer.
Oh, sorry, hold on. I got 52.5.
Okay, now, I'm not sure. I guess that's the indirect method.
Okay.
The direct method would be finding a base and a height for that gray triangle. Well, I can use this as a base. I can use, I can figure out this measure. Excuse me. I can figure out this measurement here based on the triangle number 3. And then the question is could I figure out this height there? If I can figure out the length of that red line, then the area of that triangle is the base is 3 and the height is the length of the red line.
Mm-hmm. Can't we just use the law of sine?
Oh, to figure out, yes. Not the law of sines, the area. Yeah, hold on a second. Let me make sure.
That's how, because we know the
You have your
angle.
formula for the area of a triangle based on the sides, and You know what that formula is?
No, well, he's like to find the sides, or yeah, he's
I
taught us
think
the
it's
law of
this.
sine
I
with
think
like,
it's Hero's formula. Is that what you're talking about?
I think so. It's like sine of like a over the like,
I think it's 1/2. Here, just a second. Let me look it up. I hate to do this, but I got to. I don't want to give it to you wrong. There's actually two ways to do it directly. I didn't realize you were that far in trig, that you had Hero's formula or any of that.
well, the ways that he's taught us so far is dropping the altitude, which I don't understand that much. So I just use the law of
Okay.
sine, which is
Dropping
like,
the altitude is pretty much the way they get this other direct method. Here, I'll show you. I just want to get the formula right. Area of a triangle, 464.
it's like the one with like the little a, like you have like the big A and then like the little a.
I know what you're talking about. There's actually a
Okay.
couple of them. Oh, yeah. And the other one is Heron's formula, which uses the perimeters. But the area of the triangle formula is 1/2 B times C times the sine of A. It's also 1/2 of A times C times the sine of B. Notice the pattern. It's also 1/2 of A times B times sine of C. Those are the three ways of directly finding it.
I know.
Well, we know a lot of these things. If we're going to find the area, and we're going to call this, let's see, that's a 1 square root of 2, so that's 5 root 2, correct?
Yeah.
That's 15. What's the length of this hypotenuse for triangle 2? What's the square root of 14 squared plus 7 squared?
Hold on, can you say that again? You cut out.
Can you figure out the hypotenuse on triangle 2?
Um,
The square root of 14 squared plus 7 squared.
so I just put it in my calculator, 14
You
squared.
got to be careful with your parentheses. You might want to do 14 squared, add it to 7 squared, and then take the square root of that.
Okay, and you'll get, hold on. Oh my gosh. Okay. 15.65.
Now, if we could use Hero or Heron, either one is correct, formula, it's the same formula, gives you the area based on the three sides of the length, which we happen to have.
Mm-hmm.
So we could do it directly that way. There's actually two ways to do it directly and one way to do it indirectly. We've done the indirect way, okay?
Mm-hmm.
And if we used Hero's formula, we could do it with no additional information. But if we want to use one of these three formulas, then we need those angles again.
Okay.
What is that smallest angle again? You remember what? I think it was 26 degrees. We'll just assume.
Yeah, 26 it was.
26 degrees. Okay. So the angle I'm going to use is angle A,
Okay.
which makes this side little a, and I don't care which is B and C. I'll call that B and that's C. I know what both of them are, so I'm going to use that.
Okay.
So fill it in. Area is what? 1/2. What's B times C?
15 times 15.65
Okay, times the sine of 26 degrees.
Which gets 51.46.
Total?
Yes.
And I think our other answer was 51.5.
Yes.
Doing the indirect method?
It was 52.5.
Oh, really? Wow. There's a lot of round off error here going on. Because this 15.65 was rounded off, correct?
Which one? 52 point?
No, the 15.65 number, excuse me. Why? It's hard for me to know when I'm pointing with my cursor or my
Oh,
mouse.
yeah.
You don't see it when I point with my cursor. You see it when I point with my mouse.
Yeah.
The reason the two answers are not the same is because I rounded off the 26 degrees and the 15.65. So this doesn't give me a real exact answer.
Yeah.
Whereas the first method, everything was whole numbers and it was exact. So the exact answer was the area of the big rectangle minus the area of the three small rectangles. Okay? So we've answered it. This is the direct method here. And we could improve this answer if we use the exact angle and if we used that answer out to more decimal places.
Okay.
The exact angle was probably 26.5 perhaps. I don't know. We were rounding it off just for the sake of simplicity. But clearly it introduced a round off error. You sure the first answer was 52.5 and not 51.5? I seem to remember it was 51.5. Because that's
I got 52.
Round off error. A point, more than a point. Yeah.
Because if I do the same one again, I got 52.5.
Okay.
The 26 degrees was right. I think it was the 15.65 that messed us up.
Okay. But anywhere, that's one direct method. Another direct method is to use the three perimeters, which we know. They're 15, 15.65, and 5 root 2. Now, you have to know Hero's formula for that, and that's a relatively complicated formula. Tell me if you've heard of this. Let me write it real quick just to see if you're familiar with it. It's the area of a triangle equals the square root of s times s minus a times s minus b times s minus c. And what s is the semi-perimeter. In other words, we add up the three sides, divide by 2, that's what s is.
Okay.
And
I haven't learned that yet.
You have not learned that one? Okay, that's called Hero's formula or Heron. I guess the character was either Hero or Heron. Nobody knows if his last letter was N or O. But anyway, that's another direct way. Is all you need is the three sides of the triangle.
Yeah.
In other words, you can figure out what S is by figuring out the perimeter, the semi-perimeter. And then you plug in one side for A, the other side for B, the other side for C. You'll use this. That's a direct way also.
Okay.
And I'm going to have to go.
Well, thank you very much.
You're welcome, and I'll talk to you next week.
All right. Bye. Have a nice night.
You too.